Hello, and today on the bench is this little thing I'm playing with. What is this? I hear you ask me. Well, it is a 60 kHz timecode receiver. As some of you may know, in certain parts of the world, on low frequencies, 60 kHz, 77 kHz, there's another one from Germany, there's a timecode signal sent out. And in the UK, it's on 60 kHz, and that's for all these radio controlled clocks, which once upon a time, when I first built one, cost a lot of money. Now they're cheap as chips. But mine, which I had in the workshop, hasn't worked properly for a long time because the signal was so poor. The transmitter used to be about 40 miles away at Rugby, and it was massive. I don't know what the ERP is. I think it's something like 50 kilowatts on 60 kHz, which is a lot of power. You know, when you consider how big the aerial has to be, antenna. But as I said, it didn't work properly for a long time in here. The one in the house works okay. In fact, I've got several, but so what I thought I'd do is change the receiver, because the one I've got in the one that doesn't work is salvaged out of a clock, and it's very difficult to interface it because of the way it works. It only comes on for a few minutes when it's told to by the rest of the clock, whereas this one, in theory, should be outputting a signal all the time. Now, I bought this for hardly anything. I think about £4.50 on eBay, which I thought was very good value. So I'm a little bit concerned whether it was designed for 77 kHz or 60 kHz, because he did mention DCF in the description, although it did say 60 kHz. DCF is the German one. MSF is the UK one, which is now, as I said, they've moved it. They moved it to Cumbria, which is no good at all to anybody, apart from people who live in Scotland and Cumbria, because it's now 300 odd miles away and the signal's weak compared to what it used to be. Although it should give you a decent signal up to 1,000 miles. And my watch never has a problem. Here's my watch. My radio control watch. And having took it apart many times, there's a tiny little ferrite rod underneath there, and that works on 60 kHz. And if you can see that little symbol there, that means it's had a decent reception. In the middle of the night, it does a reception, and it can't get it within the first few minutes. Maybe 1 o'clock in the morning, it'll have another go at 2 AM and 3 AM, and eventually it'll give up and wait till the next night. I'm waffling too much, but as I said, there wasn't a hell of a lot of useful information in the description, and the photographs were very pretty, just showed it from different angles, so I wasn't quite sure what the connections were. But I did get this off the internet, and it mentions P1 is the first pin to consider. That enables or disables the receiver, which you might want to do. I'm not sure why, possibly in a low consumption application. And you've got to put it low to make the receiver come on. Then you've got the time pulse output, and P2, I haven't got a P2. Then you've got the power and grounding power, and AON, AGC, there's nothing on that one, on mine. I haven't got that pin. And then there's the picture of the board underneath. Well, if I turn this one over, hoping not to do any damage to it, all I've really got on this one marked is VDD. The next one along, I would assume, looking at that picture, is ground, and it definitely is ground, because it connects to various places on the board. Then we got the P pin, which is the enable, which I've connected to earth. And then the T is the time pulse. So that is what I've done to it, hoping not to blow it up. And they tell you it works on 3.3 volts, which is a little bit annoying because my clock runs on 5 volts. But what are we doing at the moment? I did do a test on it to see if I could blow it up, and I took it all the way up to 5 volts. It didn't make the slightest difference to the current draw, and it still kept working. So it will work on 5 volts. Well, it's not a massive problem. If it was 3.3 volts, I could drop the voltage with a regulator if I had one, which I haven't, or a few 1N414s in series could drop it down to 3.3. And at 3.3 I think the logic level will be high enough to drive the 5 volt on the clock. But as it is, it's working fine on 5 volt. Now, the next problem we've got is, I noticed the clock in the lounge, which updates every minute. And I can see when it's updating. Because when it gets to 00 on the seconds, it turns that off if there's no signal, or if it hasn't managed to find a signal. So I checked on the internet. They've turned the bloody transmitter off for maintenance, haven't they? Between 8 AM and 6 PM until the 23rd of August. And today is the 19th. So we won't get a proper signal back unless I try it in the evening at 6 PM. But I've got it connected up at the moment. And I thought, well, how am I going to get around all this crap with no signal? Because it's nearly 2 o'clock in the afternoon here. And I've got no signal. But this is what we're getting at the moment. We're getting this crap. I don't know whether this is just miscellaneous noise causing this, because it certainly isn't what you should get as a time code signal. If I turn the ferrite rod around, it makes a slight difference, and I know which way to point it because it's northwest of here, the transmitter. So I suspect that isn't the transmitter. So in order to give it a proper test before the transmitter comes back, I thought, well, the obvious thing, before we get onto that crap, let's look at the current consumption. It's unbelievably large. 0.075 milliamps, 760 microamps. So that's pretty bloody impressive, isn't it? That's not going to run your clock down, battery down, if it were on battery. And so how can I test it? I thought the obvious way is a signal generator. It took me a while to work this one out, how to set it up. I don't use it on AM very often, but I've got it set to 60 kHz. And it's such a complicated signal generator. Just to set anything on it, you have to have a degree in signal generators. But I've got it to do something useful. It's on 60 kHz. It's turned, the output's turned off at the moment. 100 millivolts PD, and I'm using 100% modulation with a square wave at 2 Hz. So in theory I'm pulsing the RF output on and off. That's what I think I'm doing. Well, I am doing it. So if I turn the signal generator back on, get back on the scope, try and get it stable. Don't do that. Bloody thing always tries to move around. You'd have to bear with me. Okay. So I'm going to turn the signal generator on now and see what happens. Carrier on. Nothing happens. Why is that? Okay. I'm using a ferrite rod here. I think I must have had it a bit too far away. And basically what we're getting is a pulse, basically, a 60 kHz modulated output. No, that's all rubbish, but whatever. I'm simulating a timecode signal anyway, because that's what the transmitter does. It pulses the RF transmitter on and off, and the pulse width determines the data. Of course, my pulse width is constant, and I've got me scope on roll mode just to try and simulate what it would look like when you get the pulses coming through from the transmitter. So it does appear that I'm on 60 kHz on this module, and I've tried altering the frequency, and if I go anywhere slightly above 60 or below, even maybe a kilohertz, it loses lock completely. So all is good in the world. Just gotta wait for the bloody transmitter to come back on again. I suppose they gotta do it this time of the year because it's more or less summer, if they ever get summer in Cumbria. They do occasionally. So let's wait to see what happens when the transmitter comes back on at 6 o'clock. Okay, so it's now after 6 and they've turned the transmitter back on, and I am getting data, but it's not clean. I'm getting spikes where there shouldn't be any spikes, so it's not particularly reliable time pulse data. Now I turn the ferrite rod around, doesn't make a lot of difference. I think possibly this little ferrite rod is just not big enough to get a decent signal in this workshop. Now I'm getting quite clean data, pulses. Some of it is, and then it goes crap again. What we're looking for is clean pulses, not all these other ones that are in between, and we need at least 1 minute of clean data to update the clock properly. It may be better later on in the night, who knows, but I'm not going to stay out all night just to check it. But when we do get clean data, which is not very often, I freeze it. I don't want to. Okay, so if I've frozen it, you can see that we get pulses which are varying in pulse width, and that conveys the data to the clock. The pulse width represents the particular data signal, data bit, whatever. That's the slow code of 1 minute length, which gives you the time and the date information for the clock. There's also a fast code, once a minute, but my clock doesn't use that. It uses the full 1 minute slow code. Let's run it again. It's pretty awful really, but I mean, if it can get a minute's worth of decent data into the clock at least once every 24 hours, then it's usable. But I have a feeling I need to put a bigger ferrite rod on it. But I can't reliably do any of this until it's back in full service 24 hours a day. So I don't want to be coming out before 8 o'clock in the morning, or particularly in the evenings, to do all this. That's all I can do for now, I think. Okay, so where were we? Last time I tried it, which was last night, I was getting a very dodgy signal. So I've taken the supplied ferrite rod off. Bloody camera. Anyway, and I've put this one on, which is the one I had in the clock. And it does seem a fair bit more sensitive. There's my transmitting antenna from the SIGGEN. The SIGGEN is now set at only 1 millivolt output. I didn't need all that output I was testing with before. So, but what I'm not absolutely sure of is whether this is resonant at 60 kHz, this ferrite rod, because it's got a little tiny capacitor on the board, which obviously tuned with the old ferrite. So I have to do further investigations on that to make sure I'm actually resonant. But it does seem to work very well on a signal generator, because I've got no proper signal until this evening. But let's get things into perspective, shall we? And I'll show you what the whole point of all this is. Okay, so this is the clock in question. 6 digits, which is nice to have seconds. And it's a hell of a lot more complicated than the radio clock that you'd buy today. I'm guessing I built this about 40 years ago, and I'm not sure if I made the PCB. I might have done, I can't remember, but it's all discrete TTL, maybe the odd bit of CMOS, and a Z80 microprocessor, and somewhere there's an EEPROM. There's an EEPROM down there, which has got all the programming information for the Z80, I guess. I don't know much about EEPROMs. Yeah, this is Z80. Thought it was. So I think somebody at work programmed the EEPROM for me, because I can't cope with that sort of thing. But this here, hanging up in the air, was originally connected to the ferrite rod, and the ferrite rod was in this tube which fitted on the back, and I suspected it needed to be spaced as far away as possible from all the digital nonsense, because it's bound to upset it. And I even put a piece of mu metal, hoping that would stop any radiation getting into the antenna. But this thing in my hand is the original receiver board, and this came out of a scrap clock. Well, it was scrap after it was taken out. Now there's one slight problem with this board. It gets told to turn on by the rest of the circuitry in the clock at certain times in the night, 1 AM, and then it will only receive for 5 minutes or so, and then it stops working. This actual receiver turns itself off after 5 minutes if it hasn't got a decent time code in that time, and then the rest of the clock tells it to come back on again, then in an hour's time to do another receiving process. So that is the main issue with this. This actual board only stays receiving for 5 minutes, roughly, and there's no way around that easily. The only way I could find to get around all that nonsense and try and keep it doing as many receive cycles as possible is to put all this rubbish in here. This here is a 555 configured in an astable mode, which has a very long duty cycle, and it produces a positive supply for the receiver, which lasts about 5-10 minutes, something like that. And then it turns off again, then comes back on again, and so on continuously. In other words, it gives this receiver more of a chance of receiving the time code. So I can effectively do away with all that rubbish now, because the new one receives continuously, obviously. And this never really worked properly. And that other thing there is a transistor hanging in mid-air. That really was all that was for, was to show the data pulses as they were coming in on an LED on the front. So that's what that was all about. So where have I got to? In theory I could test it again tonight as it is, as it seems to be receiving fairly well on a signal generator. Doesn't mean it will receive the signal from the transmitter as I want it to. But now I need to work out if this is really resonant on 60 kHz. I did it the last time, so I should be able to do it this time. So I think I'll go off and do that. That's enough of that for now. Okay, I found that this was not resonant. It was, the coil had to be moved that way, and it was resonant on about 58 kHz. Not a massive difference, but it does make a difference. So it needs to have less inductance basically. And the way I went about doing that was, I'm transmitting a signal there, no modulation, just 60 kHz. And rather than connect a scope probe across the coil, as you normally do, I don't want any extra capacitance on that coil influencing the resonant frequency. So I use my homemade high impedance spectrum analyzer stroke scope probe device, which I perfected. And that's got extremely low input capacitance to load any circuit, 0.7 PF, picofarads, puffs. And what we can see now is a fairly noisy signal, but it's a signal nonetheless. And that is 60 kHz. There's other stuff going on there, probably noise from various devices in the workshop. Now if I sweep it on the generator, you can see that's 59, that is 60, that is 60.4. It's still a little bit off, but it's very close. If I go way off now, that's 68 kHz. That's way off. So back to 60 kHz. I think that's resonant, near enough. So I just got to glue that in place and hope it works. I think might as well put it in the box, the clock body box, and then try again tonight when they turn the transmitter on. Okay, aerial antenna is back in its tube. Little receiver board is mounted in there, running on 5 volts, and it's quite happy running on 5 volts, and it's all wired into that rubbish there. And what I'm doing again is transmitting with a signal generator, because I have no other signal. And this is what the clock does when it gets data pulses. It does this for a minute, in theory, until it gets a decent set of data signals. And the scope shows, where am I going? The scope shows my 2 Hz pulsing from this modulated signal generator, and the power on the signal generator, or the voltage into the transmitting antenna, is only half a millivolt now. So I think I've improved the sensitivity and got that more resonance to 60 kHz. Now I've got to wait till after 6 to see if it really works or not. I bloody hope it does, but I don't think it will. But I'll leave it on overnight if I have to, and in the morning maybe it'll get the right data, but we'll see anyway later. Well, good morning. I wouldn't normally be in the workshop at this time of day, 5 to 7, but we actually have success, and yeah, get T0, so that means a good consistent amount of data pulses. I came in here just after 6 PM last night, still getting noisy data, spurious pulses, so I left it on. I thought I'd come back and look at it later. Came back about 8:30 in the evening, and it had updated its time, so it was working. At some point it had got a decent amount of signals. So let's look at the scope. I'm a bit half awake still. So there you go, that's what they should look like. Nice clean pulses. And so I declare that it's working properly. As you can see, all the pulse widths vary, conveying different data bits. And I came in here early because I know it's going to go off at 8 and I want to get all this nonsense finished, as far as the video is concerned anyway. So I guess that's the end of this video. This particular digit is a bit dodgy, as you can see, but I may at some point change it. But there you go, it's working anyway. So that's the end of a too long video. So thanks for watching, bye for now.